These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There is a link to my website in the info box. The address is www.freelance-teacher.com/videos.htm, or you can just use the link in the info box. By the way, I also offer tutoring via Skype, and you can find more information about that Skype tutoring service at my website. Thanks. Just to get started, let's draw the product or products from here. You don't need to show the mechanism, let's just show what the product or products is. That actually seems reasonable to me. Actually, this is a little trickier than I thought. Now you have to ask yourself whether those are the same or different.
They're the same.
Then you'd only want to draw one of them? Now why are they the same?
Because if I flip it, it's the same, isn't it?
Are you thinking about flipping it horizontally or vertically?
This way.
Oh, just turning it 90 degrees? Now, if you turned it 90 degrees, they definitely wouldn't lie on each other, right? Because if you turned it 90 degrees,
Okay, yeah.
they look like this.
Mm-hmm.
Something like this.
So then they're different, right?
Yeah, I think they are different. Now, for me, the best way to do this, I think we saw this trick last time. For me, the best trick is to redraw this as if there's the double bond was like this, and then you can show the hydrogens coming in from above or from below. If the hydrogens come in from above, you would get this. I'll go ahead and show that there's methyl groups here. And if the hydrogens come in from below, we would get this.
So my answer's not right then, right?
I think your answer was right. Of course, just because your answer doesn't look the same doesn't mean you couldn't flip or rotate it to make it look like one of these. So let's see, this one over here, where you've got you got the deuterium behind. And here you got the hydrogen in front. So so you drew one like this, right? So it seems like that might be the same as...
If the deuteriums are on the same side.
You mean they're both on dashes?
Yeah.
That's right, but the reason they're both on dashes is that one is pointing up and one is pointing down. Here, the deuteriums are pointing in and out, but that's because they're both pointing in the same direction. So we have to be able to rotate this. It would help to put in the hidden hydrogen here and the methyl. So if you rotated this, that's not right. So, how did you get that?
If I drew one on a wedge and one on a dash, would be right?
So you had a hydrogen coming in from in front over here. And over here we could put the hydrogen over here, which would put the methyl over here, and the deuterium over here. And that doesn't match this. How about if we flipped it over to get the hydrogen up? Wedge. So the other thing you should do is you should put hydrogen, methyl, deuterium. Now these two are the same. These two would be the same. Okay, because if we took this and we flipped this vertically, we would get this.
Yeah.
Okay, so yeah, I think the picture you drew was correct. However, notice how hard it is to tell whether it's correct. So I think it's much easier to actually draw the double bond like this. And then you can show the hydrogens coming in from above or from below. Anyway, I get confused any other way. So also the other advantage is I think it makes it easier then to see whether your two products are the same or not. It makes them more comparable. If you draw them like this, I think it's a little bit easier to see whether these are the same or not. Or I don't know, it's still not perfectly easy. Okay, so the answer you drew, it looks like, was correct. But it's much easier to tell if you draw it like this. So are these two the same or different?
The same.
What would you do to one to make it lie on the other one? How could you flip or rotate one so that it would look the same as the other one?
No, they're different.
You might have been thinking about just flipping it vertically. But if we flipped vertically here, this methyl would be pointing down, but it would be on a dash, so it would not overlie this. Okay. So one of the hardest things here is just to be able to tell whether there's a way to flip or rotate one picture so that it looks like the other picture. And the reason that most people never learn that is they don't practice it. That is, they only do it every once in a while when it happens to come up. So what I would encourage is anytime you have two pictures and it's difficult for you to tell whether they're the same or not, make those into a flashcard. You should be getting a library of molecules that you're constantly going back to and testing yourself to see whether you can tell whether they're the same or different. So these two molecules here should be in your library of flashcards, and every day you should try to just go through it and test yourself to see whether you can see that there's no way to flip or rotate this picture to put it on this. Without practice, people don't build that skill. Now, why is it that both hydrogens come in from the same side?
Because of the, whatever that element is. 'Cause
Palladium?
It has to be on the same side because it attaches to the same side, something like
Who's
that.
it? Who is it that attaches?
Hydrogens attached to the same side of the palladium.
Good. So even though we're not going through the full mechanism here, we know that this works by the hydrogens attaching both to the same speck of palladium. Well, since both hydrogens are coming in from the same speck of palladium, we would expect them both to come in from the same side. So would this be syn or anti? Syn. So the lesson here is that when you're trying to do an addition to a non-cyclic alkene, it helps to write the alkene like this with wedges and dashes. That makes it clear what the syn and the anti-addition means.
Yeah.